Okay, now that we have our PMT levels set, our light source set up, and we have our reference data taken, we can replace the distilled water that's in syringe C and add our quenching solution and bromosuccinamide, and we will read the reaction. Once again, anytime you are loading the drive syringes, you want to make sure all air is evacuated from the syringe before collecting data. The reason for this is the air will actually allow the hydraulic system to bounce rather than stop, and you will see that bounce in the data that you collect. Once again, because I manually loaded the syringes, we want to make sure that the drive plate is against our syringe plungers. So we're going to leave the load fire valve in load, move the drive plate itself down, and make sure we see movement in both load syringes to ensure that your drive plate is against your syringe plungers. At this point, we can go ahead and move it into fire. Now, as I collect data, it's going to fire shots, and with each shot, the distilled water that's in the system now is going to be replaced with our quench solution. This is going to tell us exactly what the dead volume of the system is. So with each shot, and now we have a nice reaction after approximately 5 shots. So that tells us with a shot volume of 40 microliters total, that tells us that 100 microliters is what's required of each just to prime the system in order to get your solution from your drive syringes into the observation cell. This will give you a nice clean reaction. Now, that's 100 microliters from one syringe. Another 100 microliters from a second syringe is 200 microliters. And then we say you're going to need about 3 to 5 shots in order to average and get the data itself. So that's another 100 microliters, roughly. So that's 300 microliters minimum that you need in order to collect data with the SF-300X. That's why this model is the 300X. So now that we've got our system primed, our reaction on the screen, we can go and open a new file and collect a few shots. Once we've got a few of these shots collected, we can do things like actually average them and fit them and then export that data. So now that we have data on the screen, we can go to editing. We can select all traces, average them. If we fit that data, we can then compare from one channel to the next to make sure that our averages and our rates are similar. The absorbance channel, on the other hand, we're seeing a bit of a decrease here in absorbance, but it's on the level of millivolts. or milli-AU absorbance units of any sort of reaction. The reason we even monitor this is because this puts our signal under a microscope. If there's any anomaly whatsoever in the system, it's going to show up here in the absorbance channel before it anywhere else. As you can see, this is a very random, clean signal coming from absorbance C, and that's what we want to see. So now we will collect a new file. As you can see, we have some minor anomalies here in PMT3 that don't even show up in PMTs 1 and 2. Now if we go to File, we can save this. I'm saving it as test reaction. And at this point, we can also export this as test reaction. And that's going to give us a file that has each trace and a time that you can import into other software. At this point, our data has been collected. We can go to our system again, flush things out, and shut the system down. Once again, I tend to flush the system manually as both a check of how easily solutions can be pushed through the system and ensure that the stop valve is operating properly. At this point, some labs would be getting ready to load a second sample, perhaps, or test a different concentration. In which case, at the very least, a 3x flush is recommended. Other labs will actually run our cleaning procedure at this point. Our cleaning procedure can be found in our user manual under the maintenance appendix. The cleaning procedure should be run at least once per week for most labs. Some labs maybe a little less often, most labs more often. Because of the nature of most reactants being either salt-based or very high viscosity and prone to coagulants, you want to run the cleaning procedure more often, more thoroughly. You can use either our cleaning procedure, which uses distilled or 2 normal sodium hydroxide and 2 normal hydrochloric acid, an alternating solution of each, or you can use the solvent of your choice for your reactant if it works better for you. And this concludes the test reaction portion of the setup.